Hi everyone. In this video, I will explain some principles and rules in algebra, which is the second section of GAT test. Some topics that I'm going to talk about is the fundamental identities, linear equations, quadratic equations, exponent equations, absolute value equations, inequalities, and system of equations. So the first one is the fundamental identities. The first identity that I will talk about is the difference, the square of sum. This is the square of sum. We have to square the first one and the last one, and in the middle we will put the same sign, and then we will times 2 with the first with the second. The square of the negative, okay, so the same things, we will square the first term and we will square the second terms, but in the middle we will use this sign, and then we will times 2 with the first and with the second. Okay, let's see this one. This one is the square of difference. The difference of squares. The difference of two squares. So we can write the root. This looks like the root of the first one plus the root of the second one, then times the root of the first one minus the root of the second one. Okay. Now, if we have x plus a times x plus b, so we have to distribute these to, we have to distribute this x to this whole polynomial. Then we will distribute the second number with the whole polynomial. So we will get x squared plus a plus bx plus ab. Okay, so same things here. How can we distribute the square to three terms? Okay, this would be the distribution of the square to three terms. Okay, how can we solve linear of equations? Of course, obviously you have learned how to solve linear of equations. Some of the things that you have to know, that the equation is look like a balance. You have whatever you change from the first side, you have to do it in the second side to keep the balance. So if you have a parentheses, you have to distribute the numbers and then organize your equations. Put the variables in one side and the numbers in the other side. Then divide by the coefficient of the variables to keep the variables by itself in one side and the numbers in the other side. Okay, this is an example. If 2x over 3y equal negative 1, then negative x over y equal. So we'll start with the given with the given information. 2x over 3y equal negative 1, and we'll try to make this side equal this side. So what do we need here? We don't want, first things, we don't want this 2, and we don't want 3, and we want also to put negative. So since we don't want the 2 and the 3, we will times with 3 over 2, but both sides, since it is equation, so we don't want to change anything in the value of the equation, so we will times both sides with 3 over 2. So this 3 will cancel this 3, and this 2 will cancel this 2, and that's our goal. So we'll kept with x over y equal negative 3 over 2. Also here, we have to have negative, so I will times this with negative 1, and I will times this with negative 1. So I will left with negative x over y equal 3 over 2, since the negative will cancel the negative. So this is the final answer, is 3 over 2, which is this one. Example 2, if the product of three consecutive numbers is equal to their median, then the smaller number is. So we have three consecutive numbers. If I times them, it will give me the middle one. What are they? So let's try those options since we have an options. If I pick the smallest or the smaller one, if I pick the smallest one is 1, so the numbers that I will have, it would be, they would be 1, 2, and 3, and it should be equal to 2, and this is wrong. So let's try these options. So the 3 consecutive number would be -1 times 0 times 1, and it should be equal to the middle one, which is 0. Does -1 times 0 times 1 equal 0? Yes. Okay, so this is the correct answer. Let's try this just to clarify you understand. If the option is 2, so it would be 2, then 3, then 4. If I times them, it should give me the middle one, which is 3. But 2 times 3 times 4 does not equal 3. So this is wrong. And so do this one. 0 times 1 times 2 does not equal the middle one, which is 1. So this is the correct answer, which is -1. Okay, now we have the quadratic equations. The quadratic equations, the form of the quadratic equations is x squared plus ax squared plus bx plus c equals 0. This is the standard form of the quadratic equations. Now, how can we solve the quadratic equations? We have many methods. For example, the graphing. When you graph the quadratic equations, you can see when the graph intersects the x-axis, this value would be the answer. Also, we have factoring, and this doesn't work all the time, but the completing square and the quadratic formula is working all the time. Let's see the most things that you will need in the exam. The quadratic formula is so common in the exam. So the value under the root, which is the discriminant, b squared minus 4ac, can have 3 possible values, either 0 or a value that is more than 0 or a value that is less than 0. If it's 0, in this case, the equations has only one root. Okay, so if the value is 0, the equations has one root or two repeated solution. If the values is positive or more than 0, then the equations, the solution of the equations has two unequal real root. But if it's negative, it means has no real roots, or it has complex roots. But we don't care about complex right now, so it has no real roots. Let's see these examples. If x squared plus 6x plus c equals 0 has two equal roots, then the value of c. So in this case, we need to find the value of c, and it's given that this equation has two equal roots, which means the discriminant equals 0. What is the value of the discriminant? It is b squared minus 4ac. Okay, these equal 0. What is the value of b? What is the value of a? What is the value of c? You know that a is the coefficient of x squared. This is a. So it is 1. And b is the coefficient of x, which is 6. And c is c here. It's an unknown value. So let's put those values or substitute these values in the formula of the discriminant. So this would be 6 squared minus 4 times 1 times c equals 0. So 36 minus 4c equals 0. Now we're going to solve this as a linear equations. So I'm going to move this to the other side or add 4c to both sides. So this would be 36 equal 4c. Now I will divide both sides with 4. So the answer here equal 36 over 4, which is 9. So c equal 9. Okay, second example. If x squared equals 17, then x minus 1 times x plus 1. You can see here, this is the factors of the difference of squares. So this is x squared minus 1 squared, which is x squared minus 1. Okay, now it's given that x squared equals 17, so we will substitute the value of x squared and put 17. So this equals 17 minus 1, which equals 16. This is the answer. So don't try to do another things or to solve the equations, since you know already the difference of squares, or the difference of squares. Okay. Now, how can we solve the exponent equations? In solving the exponent equations, first, what does it mean, exponent equations? Exponent equations is that when we have x in the powers, okay, we call this exponent equations. So now, how can we solve that? If we have the same base in both sides, as you can see here we have 7 and here we have 7, so we can just go ahead and equal the powers or the exponent. So 2x plus 1 equal 3x minus 2, and now we solve this as a linear equations. So 3x minus 2x equal 1 plus 2. So all I did here is to add 1 to the other side and subtract 2x to the other side also. So 3 equal 3x minus 2x is x, so x equal 3. And this would be the value of x. Now solve this one. Sometimes it's not directly given that the base of the first side equal the base of the second side, but you can make it up by just using the powers. So you already know that 36 equal, so you have to think of a relation between 36 and 6. And you know already that 36 equals 6 to the power 2. So just rewrite this one as 6 to the power 2. So this side would be 6 to the power 2, all to the power 2x equal 6 to the power x plus 9. And now you just, since you have power to the power, you will have to multiply these two powers. So this would be 4x equals 6 to the power x plus 9. Now we have the same base, so we can equal the powers. So 4x equal x plus 9. Now you just subtract x, 4x minus x equal 9, 3x equal 9. We divide by 3, so x equal 3. And this is the answer. Okay, now let's see, this question says that if x to the power 11 equal 11 to the power x, then compute or compare between x and 11. So the only value that makes this side equal this side is when x equal 11, because when x equal 11, this would be 11 to the power 11 equal 11 to the power 11. Okay, so this is the only value that makes this statement true. So here the value of x equal 11, so I'm going to compare between value A, which is 11, and value B, which is 11. Okay, so the two values are equal. Okay, solve 2 to the power 9 plus 4 to the power 3 equal x to the power 2. So we'll just trying to get the same base here, since I can write 4 as 2 to the power 2. So 4 equal 2 to the power 2. I will rewrite this as 2 to the power 9 plus 2 to the power 2 all to the power 3 equal x squared. Now in this one I can just multiply the powers, so I will get 2 to the power 6. Okay, so I'll erase this one and write, I will erase this one and write 2 to the power 6 directly. Now I will get to 2 to the power 6 as a common factor. Be careful here, I can't add the powers since I have addition between the numbers. So 2 to the power 6 as a common factors, I will left with 2 to the power 3, because when I multiply this back, I will add the powers. So 6 plus 3 equal 9. Plus I get this all from here, so I'm left with nothing. So I'm gonna put 1, then equal x to the power 2. Okay, so now you can just find out what is 2 to the power 3 equal 8. 8 plus 1 equal 9. So this value would be 9. 2 to the power 6 times 9 equal x squared. And I can write 9 as 3 to the power 2. So 2 to the power 6 times 3 to the power 2 equal x squared. Okay, now our goal is to get the same power here. So we need to rewrite this one to get to 2. So I can write 2 to the power 3 all to the power 2 times 3 to the power 2 equal x squared. And I can write this as 2 to the power 3 times 3 all to the power 2 equal x to the power 2. Okay, since this one are equals, so I can also say that, this one equal this one. So 2 to the power 3 times 3 equal x. Actually, it could be plus or minus, but the options here is all plus. So this would be 8 times 3, which is 24. So this is the answer. Okay, solve the absolute values equations. If I have an absolute values like this one, so the first step is to get the absolute values by itself in one side. So this is 5 minus 2x equal 11. Okay, the second steps that you know that the absolute values of x is either x or negative x when x is more than or equal 0, here when x is less than 0. So the values of the absolute values could be in the positive or in the negative. So that's why 5 minus 2x is either equal 11, or I can write it in this way. So either 5 minus 2x equal 11 or 5 minus 2x equal negative 11. So in this case, I will have 5 minus 11 equal 2x, which means 2x equal negative 6. Then I divide by 2 both sides. I get x equal negative 3. And in this one, I will move this to the other side. It would be positive 2x, and here 5, and this would be positive 11. So 11 plus 5 is 16 equal to x. Then divide by 2. So x equal 8. Okay. Now the inequalities is a little bit different if the absolute values of x if the absolute values is less than a value. So we can write x minus 4 in between two values, which is 7 and minus 7. But if the absolute values, for example, is more than 7, so in this case we have two options. The first one, x minus 4, is more than the positive and less than the negative. And then we solve each part separately. So in this one, let's solve this one. We just get to add 4 to all the sides. So x less than 7 plus 4, and here negative 7 plus 4. So x less than 11 and more than negative 3. This would be the answer. It means that x is included between these two values, negative 3 and 11. But for this one, x more than 7 plus 4, so x more than 3. And here x less than negative 7 plus 4, so x less than negative 3. So when we try to graph this one on the number line, we'll see here that here is the 3 and here is negative 3. And this in this one, x is less than negative 3 and more than 3. But for this one, let me change the color. For this one, it would be included between these two roots. Okay, of course, we do not include those two values because we don't have here the equal sign. The number of the integer that satisfied the absolute values of x less than pi. You know that approximate values of pi is approximately 3.14. So the absolute values of x less than, it means that x is in between two values, pi and negative pi. So let's put here pi and here negative pi. And the value of the x should be in between those two values. So it would be included in here. So since this one is 3.14 and here negative 3.14, so the first one here is a 3, then 2, 1, 0, negative 1, negative 2, and negative 3. So the integers values that is satisfied these values is from negative 3 to 3. So how many numbers? Let's count them. So 1, 2, 3, 4, 5, 6, 7. 7 values. Which of the following is equivalent to 3 less than x minus 4? So first, just remember that when we times the inequalities with the negative, we have to flip the sign. So for example, 1 less than 2, but negative 1 is not less than 2. So that's why we can say that negative 1 more than 2, more than negative 2. Okay, so when we times the inequalities with negative, okay, when we times the inequality with negative, we have to switch the sign. So let's see here in the first one, x, we have x minus 4. So this is x minus 4 as well. And here is more, but this is negative 3 and this is 3. So they are completely different, so it's not C. Okay, for x minus 4, if we times x minus 4 with negative, we will have 4 minus x. Okay, which means if we times this side with negative, we have to times this side as well, so negative 3, and we will switch the sign, so it would be like this. So here we have negative 3 more than 4 minus x, which is B. Okay, negative 3 more than 4 minus x. This one, it looks like this side is totally different, it's 4 plus x, and here is correct. They times this side with negative and this side with negative, but they do not change or flip the sign. Okay? Okay, now what about the system of equations? Solving system of equations can be with many methods. The first one could be the elimination, and then the substitution and the graphing. Okay, let's see some of those methods during the examples. The number of a number that we divide by 5, then we divide the result by 5 such that the result was 5. So what was that number? So let's see. We have a number, okay, that we divided by 5, then we divide the result by 5 such that the result was 5. So the result was 5. So what was the number? So you can obviously see that by crossing multiple, we can just times 5 with 5, okay, and this will equal 25, then times this 5 with this 5, so the answer is 125. Okay, another way just to go back, instead of division you do times, so 5 times 5 times 5 equal 125. Okay, here we have another examples. Two positive integers numbers was such that their product is 78. So we have two numbers, their product is 78 and their difference is 7. What is the sum of these two numbers? Let's say this is x and y. What is x plus y? Okay, so in order to solve these questions, we have to factorize 78. So 78 is divisible by 2, Then 7 divided by 2 is a 3. I'm left with 1. 18 divided by 2 is 9. Then 39 is divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is a 3. And 13 is an odd number. So the factors of 78 is 2, 3, and 13. Since we need only 2 factors, so we can choose 2 times 3. This is as one factor, and the other factor is 13. Or we can choose 2 with 3 times 13. Or we can choose 3 with 2 times 13. So in this case, we have 6 and 13. Here we have 2 and 39. And here we have 3 and 26. Which options of those, if I subtract them, give me 7? So which one, if I subtract from each other, they will give me 7. Of course, this one. This is the option. So I go ahead and add 6 with 13. So it would give me 16, 17, 18, 19. So the answer is 19. This is 19, sorry. Okay, this is all about the basic principles of algebra section. I will do more examples in the future, inshallah. Thank you for watching. Bye-bye.